Welcome to emstatonline. Today topic is partial correlation coefficients. The partial correlation coefficient between x1 and x2 in a bivariate distribution is defined as the correlation coefficient between x1 2 and x2 3. x1 3 is the deviation of x1 from its estimate in terms of x3. So we consider it as a part of the variable x1, which remains after eliminating the effects of x3. However, if we want to study the effect of one variable x2 on another variable x1, after eliminating the effect of all other variables, the measure of relation between x1 and x2 is called partial correlation. In other words, the partial correlation coefficient measures the relationship between any two variables. When the other variables connected with those variables are kept constant. The partial correlation between x12 and x23 is denoted by small r 1, 2, 3 equal to covariance of x1, 2 x23 divided by square root of variance of x12 the square root of variance of x13. But covariance of 1 2 x12 and x23, that is equal to sigma 1 sigma 2 into r12 minus r13 r23. Variance of x13, that is equal to 1 by n summation of x13. Otherwise, this one we can write sigma 1 squared into 1 minus r13 squared. So variance of x2 comma 3, that is equal to sigma 2 squared into 1 minus r23 squared. And omega, so determinant value of r11, r12, r13, r21, r22, r23, r31, r32, r33, where r11 equal to r22 equal to r33 is equal to 1. So expanding this determinant value, we get omega equal to 1 minus r12 squared minus r23 squared minus r13 squared plus 2 r12 r23 r13. Let omega ij be the cofactor of rij. So example, omega 11 equal to r22 r23 r32 r33. I'm already given r22 1 r33 1, so r23 r32. So cofactor, so plus minus we can find omega 1 omega 11 omega 12 omega 13 and etc. The relation between multiple and partial correlation. That is 1 minus multiple we using capital R 2 3, that is equal to 1 minus r13.2 squared into 1 minus r12 squared. r123 is greater than r132 and r123 is greater than r12. Example, if r12 equal to 0.86, r13 equal to 0.65 and r23 is equal to 0.72. That is correlation between 1 and 2.86, 1 and 3.65 and 2 and 3 0.62. Find the partial correlation coefficient. Solution R123 is equal to R12 minus R13 into R23 divided by square root of 1 minus R13 squared into 1 minus R23 squared. So substitute the values. 0.86 minus 0.65 into 0.72 the whole divided by square root of 1 minus 0.65 squared into 1 minus 0.72 squared. So this calculator you can get the values 0.7433. If directly the value of R12, R13 and R23 given, we can use this method. Another example. In a bivariate distribution, sigma 1 equal to 3, sigma 2 equal to 4 and sigma 3 equal to 5. Here R12 0.7, R13 0.61, R23 0.4. Find the partial and multiple correlation. So first find the partial correlation. R12.3 that is equal to R12 minus R13 R23 whole divided by square root of 1 minus R13 squared into 1 minus R23 squared. That is equal to 0.7 minus 0.61 into 0.4 whole divided by square root of 1 minus 0.61 squared into 1 minus 0.4 squared. Use calculator 0.628. Similarly, we can find R132. So 0.61 minus 0.7 into 0.4 divided by square root of 1 minus 0.7 squared into 1 minus 0.4 squared. Use calculator, you can get the value 0.50. Similarly, R231 that is 0.4 minus 0.7 into 0.61 whole divided by square root of 1 minus 0.7 squared into 1 minus 0.61 squared. This calculator you can get minus 0.048. Now we have to find out the multiple correlation. First we need to find omega. Omega is equal to R111, R12, R13, R21, R221, R23, R31, R32, R331. That is equal to 1 minus R1 squared, R12 squared, minus R13 squared, minus R23 squared, plus 2 R12, R13, R23. So substitute this value. 1 minus 0.7 squared, minus 0.4 squared, minus 0.61 squared, plus 2 into 0.7 into 0.61 into 0.4. When you use calculator, you can get 0.32. Next, find omega 11. So omega 11 is the cofactor of that one, omega. Otherwise, 1 minus R 23 squared, that is 1 minus 0.4 squared, that value is 0.84. Similarly, omega 22, cofactor of omega 2, so 1 minus r13 squared, that is 1 minus 0.1 the whole squared, that is 0.63. Omega 33 is the cofactor of omega 33 in omega, 1 minus r12 squared, that is 1 minus 0.7 squared, that is 0.51. Now find the multiple correlation, capital R squared 1, 2, 3, that is equal to 1 minus omega by omega 1, 1. That value is 0.32 divided by 1 minus 0.84, that is equal to 0.62. So R2 squared of 1, 3. So 1 minus omega by omega 2, 2, that is equal to this value is minus 0.32. And this value is 1 minus, yes, minus. So this total value is 0.49. R3 squared 1, 2, that is 1 minus omega by omega 3, 3, that is equal to 1 minus 0.32 by 0.51, that value is 0.37. So R1, 2, 3, that is equal to square root of 0.62, that value is 0.79, and R213 equal to square root of 0.69, that is 0.09. That is 0.70. Then third one, R312, square root of 0.37, that is equal to 0.61. So capital R is the multi-correlation coefficients, small r1 is the partial correlation coefficients. Another one example. If R1, 2, 3 equal to 0, show that X1 is uncorrelated with X2 and X3. Solution. Already we know that 1 minus R1, 2, 3 the whole squared is equal to 1 minus R2 squared into 1 minus R132 the whole squared. Since 0 less than or equal to R12 squared less than or equal to 1, and 0 less than or equal to R13.2 the whole squared less than or equal to 1. Therefore R12, let R12 equal to 0 and R13.2 equal to 0, because that one is uncorrelated. So R13.2 that is equal to R13 minus R12 R23 divided by your square root of 1 minus R12 squared into 1 minus R23 squared, that is equal to 0. Therefore R13 minus R12 R23 equal to 0. So R13 equal to 0, since R12 equal to 0. So if capital R 1, 2, 3 equal to 0, then R12 equal to 0. So multiple correlation of R1, 2, 3 is equal to 0, then partial correlation of R12 is equal to 0. Therefore, X is uncorrelated with X2 and X3.